Well, hello everybody. It's Mrs. Pound, and I'm back with some more about minerals from Chapter 1.2 in Purposeful Designs, Earth and Space Science. So we had a lot of fun in class the other day looking at some mineral samples, and now we're going to learn some different characteristics and features that we use to identify those minerals. So today we're going to be talking about some general mineral properties from section 1.2.2. Next video will be about some special mineral properties. So our objective today is to describe the general properties of minerals and to classify minerals using these general properties. We will be also identifying some minerals in class using these properties. So one of the first things we look at is luster, the way a mineral's surface reflects light. And in the background, we see quartz. Quartz, we say, has a glassy luster because it looks a lot like glass. And some other ways we describe luster are metallic, which we looked at pyrite, which was very metallic looking, glassy, waxy, if it's kind of cloudy looking, earthy, dull, or resinous. And there's a description of some of these on page 30 in your textbook. And all of these other properties, there's a table on page 30 that's going to help us with identifying minerals. We also look at hardness, a mineral's resistance to being scratched. And in the background here, we have some talc that we looked at in class the other day. And as we can see, it looked kind of powdery, not very hard at all. When we look at hardness, we're going to use something called Mohs scale. It's used to determine the hardness of minerals, and it's on page 29. And it uses common materials that you might have on hand to determine if those materials will scratch the mineral or if the mineral will scratch those materials. And so we will be using Mohs scale in lab to help us determine the hardness of some minerals. Now on Mohs scale, and this is not a definite scale, like if each time you move up with each substance it's 10 times harder or anything. It's really a lot more relative than that, and less exact, but it is useful. People use it in the field to help identify the minerals. That's the usefulness of it, that it uses just common things. So on this scale, talc is the softest, kind of that powdery substance that we saw in the previous slide. And diamond is a 10 on the scale, and it is the hardest substance, the hardest mineral. Another thing we use is something called streak. This is the color of powder left by a mineral when it is rubbed against a hard, rough surface. This is useful for minerals on the Mohs scale with a hardness of 6 or less, because what we will use in class is an unglazed ceramic plate. We will rub the mineral against the plate, and we will see what color it leaves behind. And surprisingly enough, many of the minerals leave behind a different color than they appear. For example, I have pyrite in the black background here. Pyrite leaves a black streak. It does not leave a nice gold colored streak at all. This is much more reliable than color because streak is consistent while color may vary. We looked at our reference tables the other day. I'll show you again today, but many of the minerals have multiple colors, and so it can be tricky telling what they are. But their streak will always remain the same even if they have multiple colors. Another thing we look at is cleavage. This is a mineral's tendency to split along definite flat surfaces. Many minerals, if you were to break them, like the calcite in the background here, will have nice flat surfaces. And so that helps us to identify them, just one of the features. However, other minerals, when they break, have something called fracture. It breaks along irregular lines, and we can see here in this sample by the fingernail, it kind of looks like this has broken in a conical kind of shape, like glass. Sometimes you'll see this with glass. It's curved. And here we call that conchoidal fracture. So some minerals do not break along perfectly straight lines. They might be curved or some other irregular way that they break, and we call that fracture. Quartz, surprisingly enough, if you remember the slide previously, it has those nice angular crystals, but when it breaks, it has this conchoidal fracture where it breaks in a curved fashion, a lot like glass. And the last property that we're going to talk about is density. This is the mass per unit volume of a substance. Its equation is D equals M over V. We divide mass by volume. And its units is grams per cubic centimeter or grams per milliliter. And sometimes if you have two different samples, you will notice if they're about the same size that one feels much heavier than the other one. That's because they have a difference in density. One is much more dense than the other sample. And we talked about, if you took physical science from me, we did this extensively. We have found the density of some materials. Now, what I want you to do is I want you to use page 30 to write down the properties of feldspar. Go through each of these properties that we just talked about and write them down on your sheet. Now, I'm going to switch over to the reference tables really fast here. Okay, so here you see the earth science reference tables. This is the back page of the reference tables. This is some properties of common minerals. You will see over here there's a column for luster, and it breaks them up. The top half is metallic luster, the bottom half is non-metallic. They do not get as specific as your book on page 30. They have the hardness from Mohs scale in this column here. They tell you whether it demonstrates cleavage or fracture. There are common colors, and you'll notice that some of them have multiple colors like we talked about. So color, can use it a little bit, but not a characteristic that the only characteristic we definitely want to use. Some distinguishable characteristics. So this is where it will go into depth about the cleavage. It will talk about the streak, and special characteristics actually that we'll talk about next time also might be in that category. And then over here, the mineral name. So we will be using this resource in your reference tables along with page 30 in your book. Okay, so what we have covered in this video are objectives were to describe the general properties of minerals and to classify minerals using mineral properties. So we talked about a number of different properties. We'll cover more in another video, but remember, you're not quite finished. Write your 5 questions in your margin, and I will be back with another video about some special properties.